Hi, grade 11. So the next section is steps for solving Pythagoras type problems. We are going to be working from slides 16 to 22 from the PowerPoint's trigonometry grade 11. So I'm just going to read out a few things that's on the slides here that we're going to be using to solve this, but you'll see it in more detail once I do the example. So it says, isolate the trigonometric ratio, getting this thing on its own. Determine which quadrant the angle lies. Draw a right angle triangle in the correct quadrant, and then use Pythag to find the unknown. And then the last step, we can actually solve these questions that they're asking here. So the best way to explain this is with an example. So the first thing that I need to do is I need to isolate the trig function. So the trig function is this one over here. So if I take the 8 to the other side, I'll get 17 cos theta equals 8. Divide by the 17 and I get cos theta is equal to 8 over 17. Okay, so now what I can do is I can decide what quadrant we're in. So if we have a look at cos theta is equal to this number over here. Now I'm not interested in what this number is just yet. I'm just interested in if it's a positive or a negative number. So you can see this is positive. And if we draw our cast diagram, that will tell us which quadrant we're looking at. Okay, so where is cos positive? Well, it's positive in this quadrant, so I'm going to mark this with a tick. Negative over there, positive over here. But now you see, we still got two quadrants to decide. I mean, it could be this one or this one. That's where this bit of information comes into. So this is saying sine theta less than 0. In other words, sine theta is negative. Anything less than 0 is negative. And I'm going to mark this with an X. So sine is positive here. Sine is positive here. But it's negative in this quadrant. So mark it with an X. And it's negative in this quadrant over here. Mark it with an X. Have a look where they both agree. So they both agree over there. So we know that we're dealing with the fourth quadrant. Okay. So what I can do is I can draw my arm in the fourth quadrant. And there it is there. And I know that my angle is going to be theta. Okay. So what I'm going to do is I'm going to drop a perpendicular line from this point to my x-axis. And what I've done there is I've created a right angle triangle. What values go into this triangle? Well, we come back to what we've solved over here. And we know that x, or cos, is x over r. So I know my x value is 8, my r value is 17. So this is our x value over here. So our x value is 8, and our r value is 17. And you can see the one that we're missing is this y value. Okay? And because we've got a 90-degree triangle, what we can do is we can use Pythag to find out that missing value. So I can state Pythag, x squared plus y squared equals r squared. We know what our x value is, it's 8. So we get 8 squared plus y we don't know, so that's y squared, equals 17 squared. So we get 64 plus y squared equals 289. Take the 64 to the other side and we get y squared is equal to 225. Take the square root and you get y is equal to plus or minus 15. Now which one is it? Is it plus 15 or minus 15? Have a look at your diagram. This is the y value that we're solving for here. So we know we're going to have negative y values. So we know that our y value is equal to minus 15. Okay. What I like to do next, grade 11s, is just to summarize all our information that we've got for this angle theta. So we know what our x value is, it's 8. We know what our y value is, we've just calculated it to be minus 15. And we know what our r value, it's 17. Now we're going to use all of these to solve these questions here. Now that we've got this, we can solve this. So we know that tan, in terms of x, y, and r, is y over x. We know what our y value is. It's minus 15 over our x value is 8. For this one here, I know that sine is y over r. But because this is squared, I must square that. Plus cos is x over r. Because it's squared, I must square that. Just substitute in our values that we got here. So y is minus 15 over 17 all squared, plus x is 8 over r is 17 all squared. So we get 225 minus 15 squared, 225 over 17 squared, 289 plus 8 squared, 64 over 17 squared, 289. Denominators are the same, so we can just add the tops. So we get 289 over 289, and we get 1. Solved. Okay, example 3. Okay, so for example 3, it is telling us if 7 sine theta plus 3 is equal to 0, and this angle theta lies between 90 and 270, calculate the value of the following. Cos theta 1 plus tan squared theta. So the first thing you're going to do, draw up a Cartesian plane. The next thing, get this trig function on its own. So if I take the 3 to the other side, we get 7 sine theta equals minus 3. Divide by the 7, so we get sine theta is equal to minus 3 over 7. Okay. Just a quick thing, grade 11s. If somehow you get something like this, sine theta is equal to minus 3 over 7. I'm going to come back to that just now, when you don't know which one is which. Okay. Now we know over here that sine is y over r. Okay. Now over here, which one is the negative? Is it our y value or is it our r value? For this one, we know it's definitely the y. It's the way we solved it. But if it's like this, which one is the negative? So your r value, this r value here, can never be negative. R is a length, and a length can't be negative. The only things that can be negative is your x and your y. As you can see with your Cartesian plane, y positive, y negative, x positive, x negative. So just remember that your r can never be negative. Okay, so let's find out which quadrant we're dealing with now. I don't care what the number is just yet. I know that this is a negative number, so I'm going to mark this with a tick. Okay, and if I draw my cast diagram, okay, sine is negative in these two over here because they're all positive there and sine is positive there, so it must be in this quadrant and this quadrant. We're going to use our second bit of information now to decide which one of these two it is. Mark it with an X. So grade 11s, you remember this is going from 0 to 90, 180, 270, 360. So what lies, where is 90 and 270? Well, 90, 180, 270. So it's these two quadrants over here. So I'm going to mark it with an X, mark it with an X. Where do they both agree? In this quadrant over there. So now I can draw up my arm. And I just mark in my angle, which is theta. I drop the perpendicular to the x-axis, and we have a 90-degree triangle. Okay, so our y value is negative. We discussed that earlier. So this is negative 3. And our r value is 7. So the missing one is x. We're going to use Pythagoras to solve for what our x is. So we get x squared plus y squared equals r squared. Just substitute our values in here, and we get x squared plus minus 3 squared equals 7 squared. Okay, so x squared plus 9 equals 49. So x squared is equal to 40. Take the square root, and we get x is equal to plus or minus the root of 40. Which one is it? Is it plus root 40, negative root 40? Well, we're in the third quadrant, and we know that our x values here will be negative. So x is equal to minus root 40. Okay, I just want to summarize over here what our x, y, and r is. So x is equal to minus root 40. Our y is minus 3. And our r is 7. Okay, so cos, in terms of x, y, and r, x over r, so our x value is minus root 40 over our r value is 7. Okay, moving on to this one here, we get 1 plus, now tan is y over x, and it's squared. So we get 1 plus our y value is minus 3 over our x value is minus root 40, and that's squared. And we get 1 plus minus 3 squared is 9, minus root 40 squared is just 40. We can get an LCD of 40, and we get 40 plus 9, and that gives us 49 over 40. Solved. Right, last example, grade 11s. Okay, so it looks a little bit hectic, but it's not too bad. Okay, so it says, if tan alpha is equal to n, and alpha is acute. Now remember, an acute angle lies between 0 and 90. Calculate the value of m cos alpha plus n sine alpha over m cos alpha. So the first thing that we have to do, grade 11s, get your trig function on its own. So if I take, that's already on that side, so all I have to do is just divide by the m. So we get tan alpha equals n over m. Okay, I'm going to draw in our cast diagram. Okay, this is a positive number, so I'm going to mark it with a tick. So tan is positive over there and positive over there. Come back to this one here where it's saying alpha is acute, and I'm going to mark that with an X. Acute angles only lie over here between 0 and 90, so mark that with an X. So we have to be in the first quadrant. Okay, also I know that tan is y over x. I can draw my arm. Make it a little bit longer. And this is our angle alpha. Drop down our perpendicular. And we have a 90-degree triangle. My y value is n, and our x value is m, and we don't know what the r is. So we use Pythag to find that r value. So r squared equals x squared plus y squared. R squared is equal to m squared plus n squared. R squared is equal to m squared plus n squared. So r is equal to the square root of m squared plus n squared. Now you've noticed that I have not put plus or minus. R is always positive, so we don't have to do the negative root. Okay, so let's just summarize our values here. X is equal to m, y is equal to n, and our r value we just calculated to be the square root of m squared plus n squared. Now I can plug everything into here. So m cos alpha all over m cos alpha. Okay, I'm just going to mark it on the top here just to maybe save some space. So we know that cos is x over r, sine is y over r, and cos is x over r. Okay, so we get m. X over r is going to be that over that. m over in a square root plus, that is an m, guys, okay, plus y over r, so it's n over m squared plus n squared in a square root, all over mx is m, r is m squared plus n squared in a square root. Okay, so from here we just got some manipulation to do. So we can see that our denominators are the same here. So, and then that would be multiplied up there. And sorry, I forgot the n over there. My mistake. So m times m is m squared. N times n is n squared. All over m squared plus n squared in a square root. Now, we are dividing by this. Okay, so I can just write it on the side here just so you can see what I'm going to do. That times that is going to give us m squared over m squared plus n squared. Okay, so I've just written this just over here so you can see what I'm going to do. Because we're dividing by a fraction, I'm going to tip and times. So times m squared plus n squared in a square root all over m squared. This will cancel with this, and we're left with m squared plus n squared all over m squared. And that is our final answer. Okay, grade 11s, I would like you to do exercise 7.1, numbers 5 to 12 for me, please. Thank you.